Alright, what fraction of this rectangle is shaded? Now, they've given us a lot of information, including the length of PQ and QR, but we will not be needing these. I'll tell you why in a while. All we need are the ratios, SA, AB, BQ. Let's label the diagram. 3 is to 2 is to 5. They also told us that CR is a 3/4 of QC, which means that CR is 3 units and QC is 4 units. Before we go on, let's talk about triangles. Quick revision. If I draw a triangle here, and this is the base, where is the height? The height must always be 90 degrees to the base. That is the height. Even if the triangle is slanted like this, and this is the base, where's the height? The height must be 90 degrees to the base. So let's get back to our original triangle, shall we? I'm going to slice this into half. So now it looks like this, and we have two triangles, triangle A and triangle B. Now, imagine the base of triangle A is B1, and the base of triangle B is B2. Where is their height? The height must always be 90 degrees to the base, which means both of them share the same height. And if you recall, the area of a triangle is half times base times height. Now, we know that half is a constant. It will not change. And if both of them have the same height, the only thing that's going to affect their area would be the base, which means to say that the ratio of the base will be equal to the ratio of their area. So if I were to say that the base here is, let's say 7, and the base here is 4, then the ratio of their area would be 7 units and 4 units. It's as easy as that. So back to the question. Let's observe this pink triangle. It is half of the rectangle. And so is this blue triangle. They are equal to each other. Both of them are half the rectangle. Within the pink triangle, we notice that we have 1, 2, 3, 3 different triangles. And if I were to say that the base is 3, 2, and 5, where would the height be? The height of these three triangles would be 90 degrees to the base. It looks something like this, which means all three of them have the same height. And then we can use the base, the ratio of the base, to tell us the ratio of their area. So the ratio of their area should be 3 units, 2 units, and 5 units. Now, if you look at the blue triangle, same goes. If the base is 4 and the base is 3, where's the height? The height is 90 degrees to the base. It is right here. So these two triangles both have the same height, which is 90 degrees to the base. We can use the base to tell the ratio of their areas, which is going to be 4 units is to 3 units. But we have a problem. Can you see that when you add this together, you have 10 units, and you add this together, you have 7 units. They're supposed to be equal, right? Don't worry, let's find the lowest common multiple of 7 and 10, which gives us 70. So now I'm going to make sure that the total number of units here is 70. How do I do that? Multiply everything by 7. So 3 times 7 is 21. Let's write it down. 2 times 7 is 14. 5 times 7 is 35. So there will be a total of 70 units here. What about 4 and 3? What do they become? Multiply them by 10. 40 and 30. Okay, so now both the pink and blue triangles have the same number of units, 70 units. So what fraction is shaded? Oh, sorry, I shouldn't erase that. What fraction is shaded? Well, we know that the total area of the rectangle is 70 times 2, which is 140 units. How many units are shaded? We have 14 shaded and 40, which gives us a total of 54 units. So what fraction of the entire figure shaded? 54 out of 140. Simplify it, divide by 2, 27, divide by 2, 70, and there you go. Visualization is one of the most important things in geometry, and triangles are the most useful shape in geometry. I'll be teaching you how to make use of triangles to visualize shapes so that you can easily solve all the problem sums. Follow this account, and I'll see you again soon.